Hello friends, welcome to NEET World. This is your Abhilash Sir, Mathematics faculty. So in the previous class we started with permutation and combination, and the topic that we started is fundamental principle of counting. So today in this session we will be continuing with fundamental principle of counting, and we will be completing that topic, and we will be starting with a very important topic, that is selection. Okay, so let us get started. So what do you mean by fundamental principle of counting? I told you in the previous class it includes two principles, that is addition principle and multiplication principle. But without directly knowing the meaning of it, you cannot solve the questions. But we solve the questions using addition principle and multiplication principle. Through the questions itself you understood the meaning of addition principle and also multiplication principle, and not just that, you also understood the utility of those principles, where it is to be used and how it is to be used. Correct na? So let us continue with that. Okay, let us start with the questions afresh. Just a minute friends. Now let us start with some other questions. Okay, when it comes to fundamental principle of counting. So first question that we have is, in how many different ways? Okay, in how many different ways? In how many different ways? In how many different ways? Different ways can 5 letters be posted in 3 mailboxes if each mailbox can contain any number of letters, if each mailbox can contain what? Any number of letters. Okay, this is the question. Okay, so instead of different ways, in how many different ways, or you can write it in how many ways, you can make it in how many ways. It's not changing, just let me check. In how many ways? Okay, let it be 5 different ways only. Okay, in how many ways can 5 different letters? Okay, in how many ways can 5 different letters? In how many ways can 5 different letters? It's working now. In how many ways can 5 different letters? Can 5 different letters? So here you have to focus on each and every word. When it comes to permutation and combination, you have to focus on the question very well. See here, in how many ways can 5 different letters? Different letters means what? There cannot be repetition. So the word different itself says there cannot be no repetition. Okay, there cannot be any repetition, or there cannot be any repetition, without repetition. So they can use different words. They can use directly, explicitly saying that without repetition. Implicitly they can say at most once. The letters can be used at most once, or they can say different letters. They all mean same thing, that is without repetition. They are telling can be posted in 3 mailboxes if each mailbox can contain any number of letters. Okay, so any number of letters. So what do you mean by that? So they are telling any number of letters. So the answer can be either 3 to the power of 5 or 5 to the power of 3. Okay, so you will be confused between two answers, that is 3 to the power of 5 or 5 to the power of 3. So today I am going to end that confusion once and for all, because I will tell you one trick that will be helpful for you. Okay, even if you don't revise this, you will be able to remember that, because that is the beauty of the trick. So see here, they are telling 3 mailboxes, that is post box or mailbox, whatever it is. Okay, these are the 3 mailboxes. Correct na? So there are 5 different letters. Okay, so let us take the letters now. Okay, let it be letter 1. Okay, this letter 1 has how many possibilities? It can go into this box or this box or this box. Correct na? There are 3 possibilities for letter 1. So there are 3 possibilities for letter 1. So if I take letter 2, this also has 3 possibilities. 1 inhibitor, that inhibits 3. So this letter 2 also has 3 possibilities. Okay, 3 possibilities. What about letter 3?
This enzyme, which is released from the mitochondria.
These are 3 possibilities. 3 possibilities like this. This also has 3 possibility like this. So letter 3, letter 4 and letter 5. they also have 3 possibility, 3 possibility, 3 possibility. That is nothing but what? Multiplication principle. So 3 into 3 into 3 into 3 is nothing but 3 to the power of 5. 3 to the power of 5. So the right answer to this question is 3 to the power of 5, not this one. So the answer is what? 3 to the power of 5. So how did I get to know that letter should be placed and not the mailbox? Definitely a mailbox is a stagnant object, correct na? It is a fixed object, okay, but these letters can be moved from one post office to any other post office, but mailboxes will be kept at one post office, okay, another post office will have another mailboxes, correct na? Same thing. So the trick here is, you have to remember the trick here is, okay, whatever is fixed to the power of mobile means that can be moved, okay, fixed to the power of mobile, okay, fixed to the power of mobile. Fixed means that number, that is the mailboxes are 3, that will become the base. What can be moved or can be mobile, that is there can be movement of that, letters, anything like that, okay, that can be put on the power exponent, okay. Base will be the one that will be fixed, another thing that cannot be, that can be moved will be the in the power, okay. So for example, let us take, okay, one more example let us take. Suppose I say that 5 rings are to be placed in 5 different rings, okay, 5 different rings are to be placed in 5 different rings are to be placed in 4 fingers, okay. In this you have to identify what is mobile and what is fixed. Definitely fingers are the fixed one, correct na? You cannot cut the finger and move it, correct na? So fingers are the fixed one. So here fixed object is what? Fingers. So there are 4 fingers. What can be moved? The rings can be moved, correct na? So this is the mobile object. So 4 to the power of 5 is the right answer to this question. 4 to the power of 5 is the right answer to this question. This is how you solve this question, okay. This is one of the way to solve this question, and a very simple way. Clear? I hope it is clear. Please have a look at the solution, okay. Let us move to the next question, friends. Let us move to the next question now. Next they are telling a number log contains, okay, next question is a number log contains 3 concentric rings, contains 3 concentric or 3 consecutive rings or 3 concentric rings, 3 concentric rings with digits 0, 1, 2 up to 9, 0, 1, 2 like that up till 9, okay, done. So they are telling what is the maximum number of unsuccessful attempts to open the lock. They are asking what is the maximum number of, they are asking what is the maximum number of unsuccessful attempts, maximum number of unsuccessful attempts, maximum number of unsuccessful attempts, maximum number of unsuccessful attempts to open the lock. So this is the question, okay. So they are asking what is the maximum number of unsuccessful attempts to open the lock. They are asking unsuccessful attempts. So please focus, not the successful attempts. Now see here, let us visualize the concentric rings, okay. Say a number lock as 3 concentric rings, okay, with digits 0 to 1 to 9 that can be used, okay. So let us visualize the lock like this, okay. This will be 3 concentric rings, okay. The numbers can be like 0, 1, 2 up to 9 like this, okay. Here also 0, 1 up to 9, here also 0, 1 up to 9. So this is nothing but number lock means nothing but password. Definitely here they are not talking about a 3-digit number, they are talking about 3 concentric rings. So 3 concentric rings, I can place it like this, here like this, I can keep the password, okay. So understand one thing, this is not a 3-digit number. If it is a 3-digit number, definitely it cannot start with 0, but when it is a passcode or a password, definitely it can start with 0 and the numbers can be repeated, okay. You can keep 000 as the password, but no fool will keep a password like that. But the thing is, here we are not using what to say our rationality, here we are using just pure maths, okay. So you can keep 0 as the starting number. So definitely you cannot eliminate 0. So out of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, out of these 10 digits, any of the 10 digits can occupy the first position. Okay. Similarly, here also any of the 10 digits can occupy the first position. Correct now? I am talking about total ways. So okay, I am talking about total ways. I am talking about total ways. Here also any of the 10 digits can occupy this position, because 0 to 9 any numbers, 0 to 9 any number, 0 to 9 any number. Correct now? So this is what total ways. I am wanting what? Total unsuccessful. So this is equal to, let me write it as total unsuccessful. Total unsuccessful is equal to total ways, I am writing it here, total ways minus successful, total ways minus successful. So definitely, even if your phone, in your phone, mobile phone or whatever, if you keep the password, definitely there will be only one password to open the phone. So how many attempts are required to open it? To make it a successful attempt, there is only one successful attempt, because you have given one password. So this total ways is 10 into 10 into 1 minus successful is what? 1. Okay, out of the number of ways which you try, only one password which you have already set it, that will be the password which will open the number log. Correct now? So there will be only one successful attempt. So this will become what? This will become, total is what? 10 into 10 into 10. This is 1000 minus 1. So 1000 minus 1 will give us 999. Okay. So 999 is the total unsuccessful attempts. So out of the total ways is 1000 minus successful. Successful, there will be number of attempts that are there. But suppose you are given 010 as the password. Only when you type 010, you will get it as what? Successful attempt. There is only one possibility. So 1000 minus 1 successful attempt give us 999, that is total unsuccessful attempt. Maximum number of unsuccessful attempts, that is 999. Okay. If it is 3 concentric rings. Clear friends? This is how you have to solve the question. Here the most important thing is 0 can also come in this position, because this is not a 3-digit number. They are telling this is a 3 concentric rings. So definitely a password can start with 0 also. So I can write 0 also. They are not talking about the 3-digit number password. Okay, they are talking about, even if it is a 3-digit number password, you can start with 0, because password can definitely start with 0. Okay, clear friends? This is how you can do it. Okay, I hope it is clear. You might have got clarity on how to solve this question. So total unsuccessful is equal to total ways minus successful. Total ways minus successful. Okay, all right. I hope it is clear. Let us move to the next question. Next question is, since these questions are basic questions, I am writing it down. So when we start with JEE questions, you will have it on the PPT. So the question is, how many different 3-digit number? How many different 3-digit even numbers can be formed using the digits, using the digits 0, 1, 2, 3, 4 and 5. Okay. If each digit is to be used at most once, if each digit is to be used at most once. Okay, this is the question. So they are telling what? How many different, please pay attention, how many different 3-digit even numbers can be formed using the digits 0, 1, 2, 3, 4, 5 if each digit is to be used at most once. At most once means what? There should be no repetition, that is without repetition. That is without repetition, friends. So how to solve this question? So 3-digit numbers, definitely let us write the 3 digits, and it is even number. Even number means out of this 0, 2, 4, 0, 2 and 4 can come at this position 0, 2 or 4. Okay, 0, 2 or 4. So whenever 0 is there, let us make cases. Okay, either you can write it here itself, but to avoid confusion, let us make cases and do it. Okay, so let us make 2 cases. Okay, let us make 2 cases. This is where 0 is there. Okay, another case where 2 is there. Let us make 3 cases instead. Okay, let us make 3 cases and do it. Instead of making 2 cases, if you get confused, let us make 3 cases instead. So one is when this is the general case. Okay, one is when it is ending with 0. Okay, another one
What
ending with, it is ending with 2. Another one, let us make it, it is ending with 4. It is ending with 4. This is case 1, case 2, case 3. Okay, now what are the numbers that are given? They are given 0, 1, 2, 3, 4 and 5, correct now? So if I am placing 0 here, 0 is already done. 0 is already done. If I am placing 0 here, 1 digit is already placed. Now remaining how many digits are there here? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 5 digits will be here. Okay, suppose 1 is used here, 1 is gone. Remaining how many are there? 1, 2, 3, 4. So 4. Here multiplication principle tells us 5 into 4, I will get it as 20. 5 into 4, I will get it as 20. Now next. Okay, now next, see here again I will write. Okay, I am writing it again and again so that you understand the logic. Now all the digits are there, 2 is placed, so to remove 2, so 2 is placed means 1 digit is gone. Okay, here definitely the first digit cannot be 0 because it will become a double digit number if I place 0 here. So 0 cannot be placed here, 0 cannot be placed here. Now how many possibilities are there here? Okay, 0 cannot be placed means 1, 2, 3, 4. 4 possibilities are there. 4 possibilities are there. So let us think that 1 I have placed here. Okay, 4 possibilities are there. So now 0 can come back again here. Okay, here definitely 0 can come in the middle. So how many possibilities are there? 1, 2, 3, 4. Okay, 1, 2, 3, 4. So how many possibilities? 4 possibilities. So 4 into 4. Okay, 4 into 4 will get it as 16. 4 into 4 will get it as 16. So here 4 is placed. So 1 I will keep it here. Okay, now 4 is placed means let us assume again, see here. Let us assume we have not used any digits 0, 1, 2. Okay, 4 is placed means 4 is gone. Remaining how many are there? Remaining 1, 2, 3, 4, 5 are there. But out of 5, 0 definitely I cannot place it here because it doesn't become a 3 digit number, it will become a double digit number. Okay, so 0 I cannot place, 0 is gone. Remaining how many are there? 1, 2, 3, 4, I can place 4. But again here 0 can come. Suppose I have placed 1, what is there? 1, 2, 3, again 0 can be used. So this will become 1, 2, 3, 4. So this will become how many? 4 into 4, this will become 16. So total of these cases, now I should use what? Addition principle, that is but add all of your class, this will give us 20 plus 16 plus 16, that is equal to 52. 52 is the right answer to this question. Clear? So 52 is the right answer to this question. Clear? Got it? Okay, done. Next one. Let's move to the next question. Now let us move to the next question. So this is same as the previous question, can be used. Okay, let us use, see here. Next question is same as the previous question, but there is a twist here. So please pay attention. They are telling how many 3 digit even numbers. You may be thinking same question is coming. No, here is the twist. How many 3 digit even numbers less than 600 can be formed? 600 can be formed using the digits 0, 1, 2, 3, 4 and 9. If each digit is to be used at most once. If each digit is to be used at most once. So this is the question. So here the most important keywords are, focus on the keywords, that is at most once means no repetition, okay, and less than 600. Okay, less than 600. Okay, let us do it. So first of all, let us write it like this. So even numbers. So here what are the possibilities that we have? Okay, 0, 2 and 4, correct na? 0, 2 and 4. Let us make cases here. Let us make 2 cases. Okay, 2 cases in such a way that here let it be 0, in another case let it be 2 or 4. So let me write this as 2 Let me write this as one possibility, because two possibilities here, there is one possibility. Now what are the numbers that we have? Let me write it down here: 0, 1, 2, 3, 4 and 9. Correct na?
Yes.
4 and 9. Now observe here, 0 is gone already. Now understand here, in the hundreds place, they are telling less than 600 means definitely I cannot write 9, because it will become more than 600. So I cannot write 9 here. So how many possibilities? 1, 2, 3, 4. 4 possibilities. Okay, 4 possibilities. Suppose I have used 1. Okay, now again coming back to this in the middle number. Okay, here again see here, but definitely in the middle 9 can come. So how many possibilities? Suppose one number is used means 1, 2, 3, 4. So 4 possibilities. So 4 into 4, we will get it as what, friends? We will get it as 16. I am using multiplication principle here. 4 into 4, we are getting 16. Next thing. So I have used 2 or 4. Let us assume this is 0, 1, 2, 3, 4 and 9. These are the numbers. Correct now? Let us assume I have used 2. Okay, but there are 2 possibilities, 2 or 4. I am writing it in single possibility. I have used 2. Remaining how many possibilities are there?
Hey, what happened, man?
So see here definitely 0 cannot come, because it will not.
Yeah, you take rest and
And definitely 9 cannot,
because it is organic.
become more than 600. So definitely how many possibilities are there? 1, 3. Correct na? 1, 2, 3. This is and. This is and. Okay. 1, 2, 3. There are 3 possibilities. Now look at this. Okay. Now look at this. How many possibilities can come here? Now see here. Let me write the numbers again. So see here. We are having, what are the numbers that we have? 0, 1, 2, 3, 4 and 9. Correct na? Already I have used 2. 2 is already used. Okay. Already. Suppose I have used 1, 1 is already used. Remaining numbers are what? Here 0 can come, definitely 9 can also come, 4 can come, 3 and 3 can come. If I use 2, okay, 2 is used means. So how many possibilities? 1, 2, 3, 4. 4 possibilities. So this will become what? 3 into 4, 4 into 2, that is 3 4s are 12, 12 2s are 24. So if you add this, you will get what? 24 plus 16, that is nothing but 40. Okay. How many 3-digit even numbers less than 600 can be formed using the digit 0, 1, 2, 3, 4 and 9? If each digit is to be used at most once, the answer is 40. 40 is the right answer to this question, friends. Is it clear? Please have a look at the question. So whenever 0 is there, we will make cases. 0 as a separate case, another things as rest of the things as separate case. That will give you more clarity and you can solve the question easily and you can get the answer very accurately. That is the reason, friends. Okay. Okay. Let us move to the next question. Let us look at a different type of question. This is also based on fundamental principle of counting itself. Okay. Let us have a look at the question. So they are telling how many different 4-letter words, different 4-letter words can be formed using letters of the word daughter, letters of daughter, D-A-U-G-H-T-E-R, letters of the word daughter, okay, letters of the word daughter, such that word contains G, such that the word contains, not the words, the word contains G, such that the word contains G, such that the word contains G. Okay, such that the word contains G. So this is the question. So they are telling how many different 4-letter words can be formed using the different 4-letter words. That means there is no repetition. Okay, can be formed using letters of the word daughter such that the word contains G. So first let us write down, there should be a 4-letter word. What is from which word? The word that is daughter, D-A-U-G-H-T-E-R. Correct na? So the word should definitely contain G. So let us keep the G here. Okay, there is one possibility for G here. Okay, correct na? So let us keep G here. Okay, or let us keep G here itself. No problem. Anywhere we can keep. Let us keep it here. No problem. No, why it's not working? Okay, let us look. So let us keep G here. Okay, there is one possibility. Now, if G is left out, what are the letters that we have? 1, 2, 3, 4, 5, 6, 7. correct na? So this 7, any of the 7 letters can come here, so I should write what here, 7. Okay, suppose D is placed here, suppose D is placed here, remaining how many letters are there, 1 2 3 4 5 6, any of the 6 letters can come here, I will place 6 here. Okay, suppose I have kept A, so remaining 5 letters are there, any of the 5 letters can come here, I will place 5. So this is what I will get, 7 into 6 into 5. Okay, so 7 into 6 into 5, so 5 6 is 30, this is 30 into 7 is, I will get it as 210, 210 I will get it. But understand one thing friends, here, this G can take the place of this, that is fine, but G can come here also, or G can come here also, or this G can come here also. So for G there are 4 possibilities, why? Because the place of G can be taken in 4 different positions. So what I should do, for this number, whatever I did here, for this number I have to multiply by 4, because G can also take any of the 4 positions. Definitely the word which is to be found should contain G, but they have not specified any position in the beginning or the end. They have told it can take any position. If they have not specified anything, means it is understood that it can take any position. So G can be here or here or here or here. So there are 4 possibilities. So that means I should multiply by 4. So what I will get, 210 into 4. Okay, 210 into 4, I will get it as 840, which is absolutely correct answer. Is absolutely correct answer for this question. Clear friends? This is how we have to solve this question. Clear? I hope it is clear to all of you. Now let us move to selection. Okay, now let us move to what is called selection. Okay, let us move to what is called selection. Now let us move to what is called selection. Now observe here, very important. I told you in the previous class itself. Selection. Selection means what? Selection means you are choosing something. You are choosing something. Okay, you are choosing something. Okay, for choosing, what is that we use? Okay, permutation and combination. On that choosing or selecting, we called it as what? We called it as combination. So that means we will be studying about combination here. Okay, but before going to combination or selection, there is one more important concept under selection itself, which you have to learn, which most of you already know or you might have forgotten, but let us revisit again. So what is that concept? That is concept of factorial. What is that concept of factorial? Okay, now and let us understand what is a factorial. Factorial, it is nothing but it is a product of even numbers, in descending order. It is a product of even numbers in descending order. It is a product of even numbers in what? In descending order. So if I ask you, what is the most important keyword which you have to focus here when I talk about factorial? You may say that it is descending order, but actually the most important keyword here is natural numbers. Okay, the product of not even numbers, it should be natural number. The product of not even number, this should be natural numbers. There is a mistake here. The product of not even number, this should be natural numbers. The product of natural numbers in descending order. Make a correction. It is the product of natural numbers in descending order. That is the factorial. So natural numbers is the keyword. So suppose I write n factorial. N factorial, it is represented by like this, or you can write it like this. It remains the same. So let us write down some factorials. After that, I will tell you some properties of factorial. So observe here. Okay, 1 factorial, the value is 1. Okay, 2 factorial, the value is 2 into 1, that is 2 itself. Okay, 3 factorial, it is 3 into 2 into 1, that is 6. 4 factorial, the value is 4 into 3 into 2 into 1, the value is 24. 5 factorial, the value is 5 into 4 into 3 into 2 into 1, the value is 120. The value is what? Not 720. 6 factorial is 720. The value is 5 factorial is 120. So after 5, whatever the factorial comes, that will end with 0, because 5 factorial is 120. So 120 multiplied by any other number will also be ending with 0. Correct now? So that is the meaning of it. Okay. Now understand one thing. Let us learn the properties of factorial. Understand one thing. Suppose I write n factorial. You may be wondering why I have not written 0 factorial. Most of you know that 0 factorial is 1. Okay, most of you know that 0 factorial is equal to 1. My question is, but why and how? But why 0 factorial is 1? You will find the answer to this now. So properties of factorial. If I say n factorial, this n factorial can be written as n into n minus 1 factorial. Okay, this n factorial can be written as n into n minus 1 factorial. For example, if I say 10 factorial, this can be written as 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, correct na? 2 into 1. So instead of writing this much, I can write it as what? 10 into this 9 into 8 into 7 into 6 into 5 into 4 into 3 into 1 is what? But I can write it as 10 into 9 factorial. Same thing I have done it here. Suppose I write n minus 1, written as what, friends? This can be written as n minus factorial. N minus 1 into n minus 1 into n minus 2 factorial. Okay. Now let us understand why 0 factorial is 1. Okay. Now let us understand why 0 factorial is 1. Now see here, why 0 factorial is 1. Now by the properties of factorial, we know that n factorial can be written as n into n minus 1 factorial, correct na? N into n minus 1 factorial. Suppose I write 1 factorial. In place of n, suppose I put n is equal to 1, this will become what? 1 factorial is equal to 1 into 1 minus 1 factorial, correct na? So 1 factorial, the value is equal to 1. 1 into 1 minus 1 is 0. So this will become what? 0 factorial, correct na? This will become what? This will become 0 factorial, 1 into 0 factorial. Okay. So 0 factorial is nothing but what? 0 factorial into 1 is 0, 0 factorial into 1 is 0 factorial itself. So we will get 0 factorial, the answer is equal to 1. So by the property of this, we are getting that why 0 factorial is equal to 1. Clear? This is how you have to understand this. Why 0 factorial is equal to 1? I hope most of you got it. Otherwise, you would have just by hearted that why 0 factorial is equal to 1. Okay. Now, let us solve a question based on factorial. Now let us solve a question, simple question based on factorial, okay, by using the properties of factorial. So let us have a look at the question. The question that they have given is, okay, find n if n plus 1 factorial, is equal to 12 times into n minus 1 factorial. Find n if n plus 1 factorial is equal to 12 times into n minus 1 factorial. This is the question. Okay, this is the question that they have given. Okay, so what they are asking us is, find n if n plus 1 factorial is equal to 12 times n minus 1 factorial. So observe here, let us write down what is given. N plus 1 factorial is equal to 12 times into n minus 1 factorial. So observe here, this n plus 1 factorial can be written as what? By using our property, this can be written as n plus 1 into what I can write? N plus 1. Next number is what? The descending order. The next number is n. Okay. Into what is that I have? Next number is n minus 1 factorial. I can write it, correct na? N plus 1 into n minus 1 factorial. This will be what? 12 into n minus 1 factorial. So what I can do? I cancel this. What I am left with? N into n plus 1. N plus 1 into n is equal to 12. So let us take this n square plus n minus 12 is equal to 0. So what I will get the factors? I will get it as n square plus 4n, okay, minus 3n minus 12 is equal to 0. I am solving this quadratic equation in n, that is it. So I will get the factors as what? N plus 4 and n minus 3, I will get it. So here n will be equal to minus 4 and n will be equal to 3. N will be equal to minus 4 and n will be equal to 3. So we are getting two values of n. But what is the value I should take? I should definitely take the value of n is equal to 3, because n is equal to 3 is n is 3 is a natural number, but n is equal to minus 4 is an integer. I cannot take negative value. So n cannot be negative because n is always a natural number, okay, because we are taking factorial. So n is equal to 3 is the right answer to this question. Understood, friends? Why n is equal to 3? That's why I told, when I told the factorial definition, okay, it is a product of natural numbers in descending order, okay. It is a product of consecutive natural numbers in descending order. I should also add one word, consecutive natural numbers. This should be product of consecutive natural numbers. Product of consecutive natural numbers in descending order. Product of consecutive natural numbers in descending order. Okay, so that is the meaning of it. That's why the word natural numbers is important. So that's why n is equal to 3. Clear? Now let us go directly to selections. Now let us go directly to selections. So we understood what is factorial. So let us understand what is selections, very important. Okay, suppose assuming there are 7 different birds. 7 different birds are there. Okay, assuming 7 different birds are there. Out of this, I want to buy 4 birds to keep it as a pet at my home. Okay, 4 different birds I want to keep. 7 birds, I want to keep 4 different birds. Okay, how to select 4 different birds from 7 different birds? What I am talking about, selection. That will help me do it by using the properties of selection. So that is the meaning of saying what is selection. The definition is number of ways. In how many ways I can select 4 different birds from 7 different birds. So number of ways of selecting R objects from n available distinct objects. Here the word distinct is important. Distinct objects. Okay, is given by see here, is given by what? NCR, is given by NCR. Here the most important thing is selecting R objects from n available distinct objects. Okay, the word selection, whenever we have to select, combination comes into picture. Whenever you have to select, use the formula NCR. NCR, what is the formula, friends? NCR, the formula is n factorial by n minus r factorial into r factorial. Okay, this is the formula. Okay, now understand one thing, some books will use most of the general annotation that we use is NCR itself, but some books they will use like this NCR, or some books they can use like this also, N and R. So this is also correct, this is also correct, and this is also correct. Don't get confused. Okay, it means the same. Okay, friends. Now let us go to the properties of selection. Properties of selection. When you go to properties of selection, the first three properties, let me write down: NC0, NC1, NCN. You don't have to learn the proof of it, just understand why the value is coming. See, understand one thing, NC0 or NC0 is 1, NCN is also 1, NC1 is equal to n. Okay, NC1 is equal to n. Suppose I write NC0, why it is 1? I will tell you why it is 1. That is, NC0 I can write it as n factorial by n minus 0 factorial is n factorial itself into 0 factorial. N factorial cancel, 1 by 0 factorial is 1, so the answer is 1. NCN is the formula is n factorial by n minus n is 0 factorial into n factorial. N factorial cancel, 1 by 0 factorial is 1 by 1, so the answer is 1. That is why NCN is equal to 1, NC0 is equal to 1. Now NC1, let me write it, n factorial by n minus 1 factorial into n factorial. Okay, into, not, what is that, not n factorial, that should be what? N factorial by n minus 1 factorial into 1 factorial. NCR, R is 1. So here it is 1 factorial. So this will become what, friends? N factorial can be written as what? N factorial can be written as n into n minus 1 factorial, our property. Okay, first property is factorial property I am using. Okay, this will be n minus 1 factorial into 1 factorial is nothing but 1. So n minus 1 factorial cancel, I will get the answer as n. So these are the first three properties, and I have told you along with the proof. Okay, these are the first three properties I have told you along with the proof. You can have a look at it. Okay, these are the first three properties I have explained you along with the proof. Okay, these are the first three properties I have explained it along with the proof. Now property number 4. See here, the property number 4 is NCR can be written as NCN minus R. Okay, very important property. This is a highly important property. So NCR can be written as NCN minus R. So what do you mean by that? So see here. Let me give an example for this. If I write 10C3, what I can write it? 10 factorial divided by 10 minus 3 is 7 factorial into what is it, into 3 factorial, correct now, r factorial is 3 factorial. So this I'll get the value as what, this I'll get the value as 10 into 9 into 8 into 7 factorial will cancel, I'll get 3 factorial, 3 into 2, correct now, I'll get it as what, 2 5s are, this is 3 3s are, so 15, 5 3s are 15, 15 8s are 120, I'll get it. Suppose I write 10C7, why I am getting 7, see 10C3 I can write it as what, 10C 10 minus 3, 10C 10 minus 3, that is NC n minus r, 10C 10 minus 3 is what, 10C7, so this is equal to what, 10 factorial by 10 minus 7 is 3 factorial into r factorial is what, into 7 factorial, so this will get it as what, 10 into 9 into 8 divided by 3 into 2, so this again we will get it as what, 120, so therefore what we are getting, that 10C3 is equal to 10C7, which is nothing but, this 10C7 is nothing but 10C 10 minus 3, that is NCR is equal to NCN minus R. Why this result is important? Suppose we have to find out 100C7, okay, you will find it difficult to find out this, okay, that time what you can do, 100C 100 minus 7, so that you will get it as what, 100C93 you can find out, so 100C7 is equal to 100C93, so this is the usefulness of this result, so this is the fourth property friends, this is the fourth property, till now we have learned 4 properties. Now let us go to the fifth property, okay, let us go to the fifth property friends. Let us go to the fifth property. So fifth property says, very important property, fifth property says that, observe carefully, fifth property says if NCX is equal to NCY, then please pay attention, then either x is equal to y, or either, the word either is very important, either x is equal to y or x plus y is equal to n, So let us take an example. Suppose I write NC2 is equal to NC3, definitely 2 is not equal to 3, correct now, either x is equal to y is ruled out here. So another result that we have is x plus y is equal to n, here x is equal to 2 and y is equal to 3, x is not equal to y, so therefore we can write 2 plus 3 is equal to n, this implies n is equal to 5, So how did I get this? You may be wondering how I am getting x plus y is equal to n, correct now. So see here, x plus y is equal to n, how I am getting, so see here, NC2 is equal to, I can write it as what, NC3 can be written as what, NCn minus 3, I am using what, property 4, which says that NCR is equal to NCn minus R, I am using property 4, so as per that NC2 is equal to NCn minus 3, so now I can use either x is equal to 5, this property I will use, so x is equal to y means, that means 2 is equal to n minus 3, this implies what, 2 plus 3 is equal to n, hence proved. That is why if NCX is equal to NCY, either x is equal to y or x plus y is equal to n. This is the fifth property friends, make a note of it. This is the fifth property, please make a note of it. Okay. Now let us go to the sixth property. This is, I can also call this as consecutive property. So this is NCR plus, please pay attention, NCR plus NCR minus 1. NCR plus NCR minus 1 will give us n plus 1 CR. Okay, NCR plus NCR minus 1 will give us n plus 1 CR. Okay, what do you mean by this? So let us take an example. So if I take, okay, 100C55 plus 100C56, okay, this should come as, I should get it as 101, n is what, n should be same, so this is what, consecutive numbers 55 and 56, okay, n should remain the same, r values, that should be consecutive numbers, okay, so this is n plus 1 is what, 100 plus 1 101, CR, r is what here, 56, this is r minus 1 is 55, because the bigger number should come here, r should be the bigger number. 56 and 55, which is the bigger number? Bigger number is 56. So r will be bigger number. So 101 C 56. Let us prove this. Let us prove this. Okay, let us prove this. Let us take this LHS. Let us take this LHS. 100 C 55. 100 C 55, I can write it as what? 100 factorial by 100 minus 55 is 45 factorial into 45 factorial. Correct na? I can write it as 45 factorial into 55 r factorial to 55 factorial plus 100 C 56 can be written as 100 factorial divided by 100 minus 56 is 44 factorial into what is this? Into 56 factorial, into 56 factorial, because it is r factorial, n factorial by n minus r factorial into r factorial. So here let us take 100 common, 100 factorial common. So this will become what, friends? 101 factorial into 1 by 45 factorial into 55 factorial plus 1 by 44 factorial into 56 factorial. This is what we have. Now next thing, observe carefully. This will become what? 100 factorial. So what I can take common? Whatever is lower I can take common. I can take 44 factorial and 55 factorial as common. So this will become what? 100 factorial by 44 factorial into 55 factorial. If I take this, what I'll have? 1 by what I'll have? If I take 44 factorial, here just there will be what? There will be what? There will be just 45. 54 factorial I have taken it, so it will be 1 plus 1 by 44 factorial, I have taken 44 factorial, 55 factorial is taken out, so this will be 1 by 56 into 1. Okay, this is what I have. Now I can write this as what? I can write this as 100 factorial by what is this? 44 factorial into 55 factorial. Now if I take LCM, I will get 56 plus 45, that is nothing but 101 divided by 45 into 56. 45 into 56. If I write 44 factorial into 45, 55 factorial into 56, what I will get? I will get 101 factorial into 101 is 101 factorial divided by 44 into 45, 44 factorial into 45, I can just write it as 45 factorial, and 55 factorial into 56, I can write it as just 56 factorial. So this is nothing but what, friends? This is nothing but 101 C56, 101 C56, 101 C56. That is the right answer to this question, friends. 101 C56. Okay, that is nothing but equal to n plus 1 CR. Okay, that is what we got. Hence that is the right answer, means the property is proved. Okay, that is the right answer, means the property is proved. Okay, clear? Okay. Now let us go to next property. Let us go to next property, that is property, last property, that is property number 7. Very important property, this one also. I can show you the utility by solving one question of this. So the next property that we have is property number 7, that is NCR by NCR minus 1, the consecutive numbers in the form of quotients, that is quotient rule, that is NCR by NCR minus 1. Okay, if it is given, the answer is n minus r plus 1 by r. N minus r plus 1 by r. Please pay attention. N minus r plus 1 by r. So let us take some example. Let us take an example. So the example let us take is 25C7 divided by 25C6. So this can be written as what? N is what? 25. 25 minus bigger number. R is the bigger number. R here is what? Here r and r minus 1. Here r is what? Here r is 7. R minus 1 is 6. So I should take minus 7 plus 1 divided by r. R is what? R is 7 itself. So this will become what? 25 minus 6 is 19. 19 by 7. So the answer is 19 by 7. So this is how this property will be used. This property will be used. Now let us see a question. Let us see a question where we will apply this property. Okay, which is a PYQ. Let us see the question. Okay, the question that we have is if the question that we have is, so these are the 7 properties which we learned, and I have also given you example. Let us see the applicability of these properties in the question. So if they are telling if NCR is equal to 84, comma NCR minus 1, NCR minus 1 is equal to 36, and NCR plus 1 is equal to 126. They are asking us to find n. They are asking us to find n. They are asking us to find n. So this is the question. So this is the question they have given. So here we have to combine. Okay, this and this let us combine, and let us combine. What else let us combine? They say let us combine this and this. Okay, let us combine first one and last one. Okay, first one and last one let us combine. That is, let us use property number 7. What is the property we will use? NCR by NCR minus 1 is equal to n minus r plus 1 by r. Okay, so using that, if I apply this NCR minus 1, here what do we have, friends? Here we are having 84 by 36, correct now? 84 by 36. So 84 by 36. So this is 6 14s, this is 6 6s, this is 2 7s, this is 2 3s. So we will get what? 7 by 3. Okay, n is what here, friends? N is n itself. So we are getting what? N minus r plus 1 by r is equal to what? 7 by 3. Okay, let us cross multiply. We will get it as 3n minus 3r plus 3 is equal to 7r. Okay, plus 3 is equal to 7r. So 3n minus this, if it comes this side, minus 10r is equal to minus 3, is equal to minus 3. So let us make this as equation 1. Let us make this as equation 1. Now let us take NCR is equal to 84 and NCR plus 1. Okay, let us take that one. Okay, so what I will get? NCR plus 1 divided by NCR. Okay, NCR plus 1 is what, friends? NCR plus 1 is 126 divided by NCR is 84. Okay, NCR plus 1 by NCR. Okay, here we have to apply the property, that is what? N minus here r is what? It is not just r, it is r plus 1. R plus 1, okay, plus 1. Okay, n minus r plus 1 plus 1 divided by r. Divided by r we have. Okay, this is equal to what? This is 6 21s, this is 6 14s, 7 3s, 7 2s. We are having this is equal to 3 by 2. Okay, this is equal to 3 by 2. Now let us simplify this.
See here.
R minus 1 plus 1 divided by r. So we will get it as 3 by 2. Okay, we will get it as 3 by 2. Minus 1 plus 1 cancel. We will get n minus r by.
This is only the epidermis.
2 into n is 2n. Okay, minus 2r is equal to, what do we get? Is equal to 3r. Is equal to, we will get 3r. Correct now? Is equal to 3r. On simplifying this, we will get the answer. On simplifying this, we will get the answer. Okay. Now see here, this is 2n minus 2r. So if I bring this side, 2n minus 5r is equal to 0. 2n minus 5r is equal to 0. Okay. Now 2n minus 5r is equal to 0. Correct now? So we are having two equations. 2n minus 5r is equal to 0 and 3n minus 5r is equal to 0. So we are having 2n minus 5r is equal to 0. So let us eliminate r. So let me multiply the second equation by 2. So I will get what? I will get 4n minus 10r is equal to 0. Okay. So this and this, let us solve this, minus, plus and minus. Okay, and minus. So what I will get? This will cancel. This will be minus 2n. Minus 2n is equal to what? Minus 2n is equal to, we will get it as what? Minus 2n is equal to, this will be 10, 10 plus 10. So this will be 4n. Okay. Just let us check. Okay, let us check. So this will be 2 2s are 4. This will be 2 5s are 10. 2 0. Let me check once. Let me check once. Okay. Here we have done one mistake. Here we have done one mistake. This should be r plus 1. Because this is r plus 1, na? Denominator should also be r plus 1. So this will become what? This will become r plus 1, means this will become what? See, observe here, this will become, observe here, this will become, here r is what? It is not just r, this is r plus 1. So this will become r plus 1. So this will be 2n minus 2r is equal to 3r plus 3. 3r plus 3. So 2n, this will be 2n minus 5r is equal to 3. So this will become not 0, this will become plus 3. So this, if I multiply by 2, I will get it as minus 6. This, if I multiply by 2, I will get it as minus 6. So this will be 3n minus n is minus n. This will be minus n. So minus n. Okay. So minus n. So 3n minus n is minus n. So minus n is equal to minus 9. So this implies n is equal to 9. So we will get the value of n is equal to 9. No need to find out the value of r. They have directly asked n. So, directly you can find the value of n. So, this is the property you can use, that is the 7th property we are using to find the value of n. You can find the value of r also, but here directly you can find the value of n by eliminating r. Okay, you can find the value of n, you can find the value of r, anything is possible. Okay, you can combine first and second, or first and last, or second and third one, anything you can combine, you can find the answer to the question. Clear? This is how we have to solve this question. We will get the value of n is equal to 1. Here you should be careful that while taking r, it should be r plus 1. This is r plus 1 means here also r plus 1, denominator also it is r plus 1. Okay, clear? This is how we have to solve this question. Clear? So, this is how we have done the questions on selections. So, we will continue with some more questions in the next class, and we will go to another concepts of permutation and combination. Alright friends, thank you. Please stay tuned for NEET World. Thank you. Take care.